Ladies, I appreciate you tuning in so that you can get the notes part of this out of the way and we can really work together in class to make sure you understand exponential functions and their graphs. So our first goal is to recognize and evaluate exponential functions with base b and to graph exponential functions with base b. So as we evaluate exponential functions, we'll use those to help us graph. So how do you recognize an exponential function? Y equals 2 to the x. I know that's an exponential function because the variable x is inside the exponent. So the base of x is 2. So we're going to evaluate 2 raised to the x power and then graph it here. So let's create a table of values using these x coordinates. So let's evaluate 3, 2, 1, 0, -1, -2, and -3. You're welcome to use your calculator to crunch these numbers. So let's get started. Let's begin by raising 2 to the third power. You know that 2 times 2 is 4, and 4 times 2 is 8. 2 to the second power, 2 times 2 is 4. 2 to the first power is 2. What about 2 to the 0 power? Remember the rule you learned probably back in middle school. Any number raised to the 0 power is equal to 1. How do we raise 2 to a negative exponent? Remember that a negative exponent implies the reciprocal. So this implies that we have 1 divided by 2 to the first power, or 1/2. Notice how 2 to the -1 is the reciprocal of 2 to the +1. So 2 to the -2 is the reciprocal of 2 to the +2, which is 1/4. Finally, 2 to the -3 is the reciprocal of 2 to the +3. So the reciprocal of 8 is 1/8. Okay, we could continue to use other integers, -4 and 4, -5 and 5, but I think we have enough points for our purposes. So let's plot these points on our coordinate plane. Right 3, up 8 doesn't quite fit on our coordinate plane, but we can estimate. Right 2, up 4. Right 1, up 2. Over 0, up 1. Left 1, up 1/2. Left 2, up 1/4. Left 3, up 1/8. And as you notice, as we continue to travel left, we're getting closer and closer to the x-axis. So let's think about this for a moment. Will we ever cross the x-axis? Is there any value that I can raise +2 up to, and it will change the +2 into a -2? We've already shown when we raise to a negative exponent, it just gives us the reciprocal of the positive. So we will not cross the x-axis. So that means the x-axis acts like an asymptote. So I want you to draw an asymptote across. That is the most pitiful straight line. I'd like you to draw an asymptote across the x-axis so that you know not to cross over it. I'll draw it a little bit differently. There we go. Okay. So now let's connect our points. And this exponential function, notice, is increasing as we move from -infinity to +infinity. Let's do the same process with example B. We are also going to raise, we will also use the same table with our x coordinates. So go ahead and set up your table. So we've got 3, 2, 1, 0, -1, -2, and -3. So 1/2 is our base. 1/2 raised to the third power. So that's 1/2 times 1/2 is 1/4. 1/4 times 1/2 is 1/8. 1/2 raised to the second power. 1/2 times 1/2 is 1/4. 1/2 raised to the first power is 1/2. 1/2 raised to the 0 power. Remember, any number raised to the 0 power is 1. 1/2 to the -1 power. Here we go with negative exponents again. This is the reciprocal of 1/2 to the first. 1/2 to the -2 power. This is the reciprocal of 1/2 squared, so 4. 1/2 to the -3 is the reciprocal of 1/8 or 8. So let's plot those points now. All right, so write 3 up 1/8, write 2 up 1/4, write 1 up 1/2, over 0 up 1, left 1 up 2, left 2 up 4, left 3 up 8. You should notice again that as we move in the positive direction along the x-axis, we are getting closer and closer to the x-axis, but we will not cross that x-axis. So let's draw a horizontal asymptote there so we remember not to cross it. And connect our points. So this function is decreasing from -infinity to +infinity. Sorry, that got kind of off right there. What I'd like you to do at this time is to compare the bases of each function. Notice that the base of A is a value greater than 1, B for base. The base, for example, B, is between 0 and 1. So functions whose bases are greater than 1 are increasing. Exponential functions whose bases are between 0 and 1 are decreasing. What I'd like for you to do right now is pause the screencast and identify the following information. Okay, ladies, let's see how you did on identifying this information. When the base is greater than 1 and when the base is between 0 and 1, notice that the domains are both all reals. The ranges are from 0 to +infinity. Neither graph has an x-intercept. Both graphs have a y-intercept of 1. They are both continuous from -infinity to +infinity. They are both 1 to 1. Remember, that's when they pass the vertical and the horizontal line test. Remember that if a function is 1 to 1, it has an inverse, and that will become important to us in a day or two. And then we do have a y-intercept or a horizontal intercept of y equals 0. So everything is the same with these functions except whether or not they are increasing or decreasing. So how do you know when an exponential function will increase or decrease? If the base is greater than 1, the function will increase as we move from left to right. If the base is between 0 and 1, the function will decrease as we move from left to right. And I want you to think of these two functions as the parent functions for exponential. A horizontal asymptote along the x-axis, a y-intercept of 1, and increasing to the right if the base is greater than 1, and decreasing to the right if the base is between 0 and 1. Let's talk about recognizing, evaluating, and graphing exponential functions with base e. The number e is found in this way: 1 plus 1 divided by 1 times 2, plus 1 divided by 1 times 2 times 3, plus 1 divided by 1 times 2 times 3 times 4, and so on and so forth. And so if you turn all of these into decimal values and add them, you get approximately 2.718. Now this is an irrational number, so it continues going, but I just rounded it. This is the natural number, E is the natural number, and this is the natural exponential function. So if you look at this function, E is approximately 2.7, so it is greater than 1, so it is an increasing function. Just like our previous example, 2 to the x power was also an increasing function. So this is going to look a lot like any other exponential function. So I just wanted you to recognize that. Ladies, I'd like you to take a piece of graph paper, and for your first 2 practice problems, section 3.1 goes 1 through 3 practice. Please complete what I asked for A and B. When you finish that, you do need to pick up and continue completing your 3.1 notes by watching the remaining screencast. Thank you.